Hello students, welcome you all. Now in today's lecture I will explain this E1cB reactions. Now in last lecture I told you about the E1 reactions. So this E1cB reaction, the full form for this E1cB reaction is elimination unimolecular conjugate base reaction. Okay, so it is elimination unimolecular conjugate base reaction. Now let's see some before giving you the examples of this E1cB reaction. So let's see some important features of this reaction. So one of this like that of this E1 reaction, this is also two-step reaction. So this is two-step reaction which occur with the formation of two transition states and one intermediate. With the formation of two transition states and one intermediate. And here the intermediate is carbon ion. So in E1 reaction what we saw, the intermediate was carbocation. So here intermediate is carbon ion. Or this carbon ion, or this occurs with the formation of as a conjugate base. So conjugate base of this alkyl halide that would be formed. Okay, so conjugate base, or we can say conjugate base of alkyl halide is formed over here. Okay. Now in this reaction, the first step occurs with the formation of carbon ion, and in second step from carbon ion alkene is formed, whereas the first step is here. So one of the difference with this E1 reaction, here the first step is fast step and second step is the slow step, whereas in E1 reaction what we saw, the first step was slow step and the second step was the fast step. So here the first step is fast step and carbon ion is formed. Whereas the second step is slow step and alkene is formed from the carbon ion. Alkene is formed. So if you see the energy profile diagram for this, then energy profile diagram for this E1cB reaction, we can say this energy profile diagram is just a mirror image of this E1 reaction. So the energy profile diagram for this, it is something, if it is reactant, and here the first step is fast step and the second step is the slow step. So this would be the energy profile diagram for our E1cB reaction. Okay, and here if we see, this is one of the intermediate, this is transition state 1 and this is transition state 2. So this is E1 reaction, this is E1, that is activation energy first, and activation energy required for this one, this is the activation energy required for this step. So no doubt this E2 is more than this E1, E2 is more than this E1, and that's why this step is the slow step and this step is the fast step. Now what was I told you in E1 reaction? In E1 reaction, the energy profile diagram was this. This was the energy profile diagram for E1 reaction. So we can see that this is mirror image. It is most like that of this mirror image of the E1 energy profile diagram. Next feature, this reaction, it follows the first order kinetics, like it is a unimolecular reaction, so it follows first order kinetics. First order kinetics. And the rate of reaction, it only depends upon the concentration of substrate. Okay. Though this reaction occur in presence of a strong base like that of E2 reaction, then also the rate of reaction only depends upon the concentration of substrate. Okay. So it occurs in presence of strong base. In presence of strong base. Like sodium ethoxide. Okay, and next one, so sodium ethoxide, it will remove this beta hydrogen atom, it will deprotonate this beta H, and this carbon ion is formed. Okay, and then in second step from carbon ion, this alkene is formed. And next, one of the feature is that it may occur in presence of some poor leaving group also. Okay. Like this in E2 reaction, the leaving group, that should be the strong leaving group, good leaving group. But here, this may occur in presence of poor leaving group. May occur in presence of poor leaving group. For example, the poor leaving groups like fluoride ion, or it may be hydroxide ion, it may be methoxide ion, like that. Okay, and also in E2 reaction, what we have seen, the leaving group and the beta H, that should be anti-periplunar to each other. So there is some stereochemical requirement in the substrate molecule in case of E2 reaction. But here there is no requirement of stereochemistry in substrate molecule. So stereochemistry is not involved in the substrate molecule. Stereochemistry is not involved in substrate molecule. Another important feature for this reaction, the beta H, the presence of some electron withdrawing group at the beta H. Suppose if we have this leaving group, and this is some of the beta H. So this is a leaving group, this is alpha position, this is beta position. So at beta H, the presence of some electron withdrawing group at this beta H. If electron withdrawing group is present over this beta carbon atom, then the reaction that would be favored, and the rate of reaction, or we can say that rate of reaction is increased in presence of electron withdrawing group at the beta carbon atom. So how that I will tell you, because at beta carbon atom a carbon ion is formed, and this carbon ion, that would be the negative charge over this carbon ion, that would be neutralized by this presence of this electron withdrawing group here. Okay, so I will give you the example. So the presence of electron withdrawing group at beta carbon atom favors the E1cB reaction. Why? Because this electron withdrawing group, it neutralizes the negative charge over the negative charge of this carbon ion. So this is the reason. So let us see some examples. So let us explain it with the help of example. So if we take example, then suppose this is our leaving group and this is alpha carbon atom, this is beta carbon atom, this beta hydrogen atom, and suppose one of this methyl group is present over here, another methyl group, and these are the, suppose if we see this is okay. Now here this leaving group, it may be either poor leaving group, it may be poor leaving group, any leaving group. Now, so this in presence of suppose sodium ethoxide as a strong base, what I told you, strong baseness is necessary in this reaction. So this strong base in presence of this, it will give you the product, this leaving group that will leave out. Now if we see the mechanism of this reaction, then in mechanism, first of all, what will happen? This sodium ethoxide that will so this will take this beta H, so this is alpha, this is beta H, and a conjugate base that would be formed over here, the carbon ion would be formed. So if you see, then one of the carbon ion is present in this orbital, or and so this is step here, this step is the fast step, and in second step, which is a slow step, alkene is formed with the removal of this leaving group. So second step is our slow step, and we will get the alkene molecule. Okay, so here this is the conjugate base or the carbon ion intermediate which is formed. So if you will see here, two transition states and one intermediate is formed. So one of the transition state that would be formed over here, and another transition state would be formed here. So suppose if you want to draw the transition state, so one of the transition state that would be formed in between this first step and second transition state in between this second step, this is the first step. So if we want to see the transition state, then suppose this is the leaving group. So this will here one of this hydrogen atom where the bond will start breaking out in transition state, the bond breaking and bond formation takes place. So here this bond will start breaking, bond between this beta H will start breaking, and a new bond will start form between this ethoxide ion. Okay, so this is our base. So here this will have the partial negative charge, whereas this hydrogen will have the partial positive charge. So this is one of the transition state that is formed. Okay, this is one of the transition state which is formed. So suppose this is transition state 1, and here also one of the transition state that will be formed, where this leaving group, this bond, the bond between this carbon and leaving group, that will start breaking and a new pi bond will start forming. So the transition state here, so this is the new pi bond which is start forming, whereas this is the new this is the bond which is start breaking out. So this is our transition state 2. Okay, and if you want to see this energy profile, the energy profile diagram was something like this. So this is our transition state 1, this is our transition state 2, and this is the intermediate, this conjugate base intermediate is formed, or this carbocation intermediate is formed. Okay, now in the same way we may see next another example. So one of the famous example for this E1cB reaction, that is the aldol condensation. So now one of the famous example of this E1cB reaction is the aldol condensation. Okay, suppose if we have a beta hydroxyaldehyde. So if we have a beta hydroxyaldehyde, okay, so suppose this is beta hydroxyaldehyde, and this in presence of strong base, suppose it is NaOH. Then in first step this conjugate base is formed, or this carbon ion intermediate is formed. So here this hydrogen which is present, this alpha to this aldehyde group. So this hydrogen, this is the acidic hydrogen one. Okay, and here the presence of this electron withdrawing group, it favors the formation of this conjugate base. So this will take out one of the acidic H over here, and the conjugate base that will be formed. Okay, so this negative charge that would be neutralized by this aldehyde group, which is the electron withdrawing group. And in next step, so this step is a fast step, whereas this step is a slow step, and in next step the OH as a leaving group, which is a poor leaving group, that will leave out. And we will have a alpha beta unsaturated aldehyde that will be formed. So we have alpha beta unsaturated aldehyde, which is formed in a aldol condensation. In the same way, we may take another example. So here also, if we have suppose sodium ethoxide as a strong base, so first of all this H that will, being this acidic H, it will be moved out and a carbon ion is formed, and this carbon ion which is formed, this is being stabilized by this electron withdrawing this carbonyl group which is present over here, and in next step this carbon ion here, so this OH being the leaving out, it will leave out, and we will have this product. we will have this product. Okay. In the same way, another example, if we take here, so suppose I take one of the alkene. So in alkene to alkenyl bromide may give you the alkyne also. So one of the this is the example of E1cB reaction. So suppose if we have this bromine over here and one of the so this is alkenyl bromide. So this also gives this E1cB reaction. So how? Suppose if we have a strong base as a sodium amide. This sodium amide as a strong base, it may takes one of this beta H. So it may take one of this beta H. So suppose this is the alpha and this is the beta one. So it will take out this beta H and one of the intermediate which is formed over here. Here you will have this intermediate. Okay. So the formation of this intermediate carbocation or conjugate base, carbanion, this is stabilized by here this carbon. If you will see, this carbon is sp2 hybridized carbon. So this sp2 hybridized carbon being the very electronegative carbon, so that will stabilize this negative charge. So here the formation of this carbanion is favored due to the presence of this sp2 hybridized carbon over here, and in next step this will, the bromine being leaving out, it will leave out and we will have this alkyne that would be formed. So this is another example of this E1cB reaction. In the same way, suppose another example is the nucleophilic aromatic substitution. So nucleophilic aromatic substitution reaction, which occur with the formation of alkyne as this benzene as intermediate. Okay, so aromatic substitution. And here one of what intermediate is formed, benzene intermediate is formed, benzene mechanism, occur via the benzene mechanism. So if we have, suppose, fluorobenzene, this in presence of sodium amide, in presence of strong base. So we will discuss this nucleophilic aromatic substitution in my coming lecture. I will give you one of the lecture over this nucleophilic aromatic substitution. So this will this sodium amide, it will take out one of the ortho hydrogen from here. Okay, it is similar to that here also. So this carbon being the sp2 hybridized carbon, so it favors the formation of this carbanion or conjugate base intermediate. So this will take this acidic H, and here one of the this intermediate is formed. Okay, and next step, what would be formed? A benzene is formed. And this fluorine it will leave out. So formation of this benzene is also an example of this E1cB reaction. Formation of this benzene intermediate. This is the intermediate. And further, this will, in presence of this ammonia, actually this reaction occur in presence of ammonia, and we will get aromatic amine that is formed further. Okay, so these are few examples of E1cB reaction. Okay, thank you.